So, thank you very much for the nice introduction. I'm Alice Bertoletti, and I will present today this paper. This is a joint work together with some former colleagues at Politecnico Milano, Marta Canestrana and Mara Soncini. And in this paper, we want indeed to explore the gender gap, but looking more focusing on what could be the influence of females role models in trying to mitigate the gender gap and try to have an effect on mathematical achievement of girls. Sorry, but the PDF now is in. So I will be very short on this since we already have all the session on the gender gap. So we know that Italy exhibits a quite significant gender gap in favor of girls in mathematics, and this of course is very important because this disadvantage of girls in mathematics can influence the later on careers of females, and then disintegrating what is the choice of STEM careers, STEM courses at university, and for this reason it's creating inequality between males and females also in the society. So what we know from the former INVALSI reports is that we have disparities, a difference between females and males in mathematical achievement, and we can see these disparities already at grade 2, and this continue to persist also throughout along the student career. So what the idea is here is to look more into the role models, and indeed has been highlight how role models can serve as a powerful policy tool in order to mitigate what are the stereotypes, especially in STEM and for girls. And if we look at the literature, we can identify two main role models. One is the mother, and the others is the teacher, the same-sex teachers. So looking at this literature, what we can see that is indeed based on a survey on the UK students in elementary and middle school. What we see that indeed a large percentage of students, 60%, is indicating parents as their role models, and especially girls are indicating female relatives as their role models. Also, we have, based on previous papers, what we have evidence of that the entrepreneurial interest of course is pretty much influenced by having entrepreneurial parents, and this, however, is not significant or as significant for girls, also for boys. So this mechanism is larger for girls. And also we know that mothers can shape quite significant the daughter's self-efficacy, and that could be happen both in a passive and active way. What we know for the same-sex teachers, we have literature saying that indeed having a female instruction for girls is encouraging them to choose STEM courses at university. But if we look only at the school attainment, what we can see here that the effect seems limiting the size. We based, for example, this is a quite recent paper by the Grand et al. That is saying that overall, with a lot of observation in 3 million students observations in 6 continents, they found that the effect of having same-sex teachers, both on boys and females, in this case, has a significant effect, but is only 0.015 standard deviation. And indeed, what also we are referring was that sometimes it's not sure that teachers can represent role models for the students. So, given this background, what are our research questions? Is with this paper we want to analyze the influence of female role models in explaining and mitigating gender gap in mathematical achievement. For doing this, the first question is to measure and estimate gender gap. You want to do this along the student career. And then, with the second research question, we go more in the focus of the paper and want to see how these female role models can influence the standardized test scores, of course, especially compared to boys. And finally, also a little bit of heterogeneity between grades and regions. Here, today, I will present what are the results in terms of mothers, so the maternal role models, and I will explain also the empirical strategy for the teacher role models, but however, as we are still waiting for the data, so the results are not available today. So what we have now is data. We will base our analysis on INVALSI data, and of course our standardized test scores in math, plus the characteristics of the students, some demographic information about school and students. Then what is quite novel, one of the novelty of this paper is that we use panel data, in this case a balanced panel data, because we are only selecting all the students that we can track over grades. And as you can see here in the picture, what we have is that we base on the entire population of Italian students that in 2012 were in grade 2. Then we can move on and we can see also the same cohort of students. These are the same students in 2015 that of course will be in grade 5 and so on for in 2018 grade 8. Here we stop here also because this is the last year of INVALSI data that we have, that is before pandemic, and to have more like neutral to the COVID pandemic effect, we use this cohort of students. Of course, can be also replicated for the other cohorts. So this is the main structure of the data. For the empirical model, what we have here we use is a dynamic panel model. This point here is to try to exploit what is this, what we have to the panel data, the ability to track the same course over time. And so this model is a regression, but as one of the regression of one of independent variables is the previous achievement at time -3, so the previous grade that is available on INVALSI. Then, of course, other variables, independent variables that we have in the models are, of course, gender. This is essential to measure the gender gap. There are some variables for measuring the role models and all the student characteristics and fixed effects, like geographical fixed effects and grade fixed effect. So, of course, this is very important to this dynamic model to have and to control also for past achievement, but is introducing also a problem of endogeneity. So, looking at the literature, what we use here is approach to try to limit this bias of endogeneity is using an instrumental variable approach. In this case, following the strategy proposed by Continent Grant and Continental 2017, we use the month of birth as an instrumental variable. And the idea is that indeed the younger students have a lower achievement than older peers, especially at the first grades of the career. And but while later achievement should not depend so much on age in terms of month, and given also that we control for a previous achievement. So So this is our results, and this is the gender gaps. We can see here is a light, is the effect on the female effect, and we can see that in all models we tried, the first three are different in terms of sample, because it's a very big sample. So the idea is also to see if the same effect is still significant using a more reduced number of observations. This is indeed what we found. As you can see, it is for all grades. I will highlight here that is a quite important difference between not dynamic and the full sample dynamic, for example. And because this is not dynamic, so when you not control for previous achievement, you tend to overestimate the gender gaps. So that is almost the double of the dynamic model. And we have the same for basically also divided by grades. This is, of course, here we cannot use grade 2 because it can enter only on as previous achievement, and not as because we don't have a previous achievement for grade 2. And we have here that quite interesting that in grade 8 the instrumental variable approach does not found a significant effect. Okay, so this is also some heterogeneity across regions. And what we can see here is pretty clear. The northern part of Italy does not display a gender gap in this favor, of course, or sometimes it is also the opposite. So males are, so girls are going better compared to boys. But in the south we have a quite important gender gap. Actually, it's very interesting to see how this is the difference between grades. So in blue we have grade 5, in red grade 8. And you can see here that we are in the north and south we have opposite situation. So the regions in the north start with a significant gender gap in this favor of girls, but then they can recuperate all this advantage during the school system. At grade 8, the effect is positive, so they compensate this gender gap through education. But in the south, it's the opposite. There is no significant gender gap when they start. This is a grade 5 elementary, but then in grade 8, this is very negative effect. So the gender gap is increasing, especially in grade 8. So here, to enter in the gender, how measuring maternal role models, the first variable that we use is indeed if there is a working mother or not. Here we have information about the jobs, but it's very of the mothers, but it's very basic. So we cannot unfortunately differentiate between, for example, STEM careers for mothers or not. So what is the basic here to use if the mother is a working mother or is unemployed or housewife? And we can see here that the percentage of working mother is not so high in Italy, especially in the southern regions. And what we found here is indeed there is a positive effect of course it is a positive effect of working mother, but this is larger for females compared to boys. So this somehow goes in the direction that exists this kind of role models, especially for girls, so the mother can influence the achievement in math of the daughters. And so here is a minus because the reference is a working mother, so it's not a working mother for boys, and here it's compared to it's not a working mother for females. So this basically say is the negative effect of having a housewife or an employed mother is more negative for girls than for boys. This is maybe I don't have time for this is for the differences between regions and grades, but however the effect is almost not in grade 5 in the south, but stay significant. but it does not emerge a kind of very clear path across geographical areas. Indeed, what we see is the highest effect in terms of, so this negative effect is for grade 8 and in the center of Italy. So we try also with, in terms of the mother, we can see also if the level of education the mother can shape the achievement of course. And here we are considering this categorical variable that we have in INVALSI, measuring the educational level. And however, in the results, we cannot find any difference. So of course, educational mother has a positive effect on the, in general, on the results in math of all the students, but there is no difference between boys and girls. So if I have time, maybe I will present just an idea of the next step, so working on teachers. The first step is just to assess with a mixed multi-level models how the class can matter in terms of explain the difference between the achievement in math of girls and boys. And here we can see that indeed the class level, this is level 2, is indeed can account for almost half of unexplained variability in student performance, and on about 20 in the grade 5 and the grade 8 a little bit less, 23%. And here the 5% of these it can be related to the gender random slope, so specifically to the gender gaps, you can say at the class level. So the final slide is one to see if the idea of our next step, and of course we would like to highlight if there is an effect in the on the achievement of girls and boys when there is a change of the sex of the teachers. So here we have like two different treatments, from females to males, from males to females, and when you see as a control when the teacher remains the same, or is changing but without a change in the sex. And the idea is to use only grade 2 and 5 to be remain in the same school, so in elementary school this will be more homogeneous. And then, of course, we know that the treatment group will not be very, very numerous because there are a lot of female teachers. But the idea is to look if we have enough information about this change, so would be large enough and have a control that we can select the more similar students as a control with the limited, of course, the number of the students in the control group. So, very last slides, just some preliminary takeaways. It's quite important to measure gender gap in dynamic model, otherwise there is the risk of overestimated gender gaps, and you can be also more precise about the mechanism that can explain the gender gap. And the second point is also that role models, there is significant variation across regions and grades, so also these can be, of course, taken into consideration, and not only the bilateral sums, but also the combination, as we see different paths between grade 5 and grade 8. And the last is that maternal role models can indeed have a potential in influencing, especially the achievement in math of female students, especially we can see this difference between having a working mother or not having a working mother. So that's it. Thank you.